this was subsequent to a basic session on ellipse. I still have to deliver some more ideas on ellipse, but subsequent to a very basic session on ellipse that we've already had, we are pretty geared to handle the sheet. This was given to you yesterday. I'm assuming you would have browsed through these problems, hopefully attempted most of them, right? So this sheet titled Ellipse Sheet 0. Right? So the first problem of this sheet is about a certain ellipse. This is the major axis of the ellipse. This is the minor axis of the ellipse. This is the center of the ellipse. The minor axis, say BB prime. It is known to subtend a right angle at the focus. This BB prime subtends a right angle at the focus of the ellipse. We need to find the eccentricity of the ellipse. Clear? So let us assume that A is the semi-major axis and B is the semi-minor axis of the ellipse, as is customary. E is the eccentricity of the ellipse. Now, this is the directrix of the ellipse, right? BC is small b, right? BC is small b. Now, this distance, BM, is the distance between the minor axis and the directrix, which is always A by E, isn't it? Distance between the center and the distance between the minor axis and the directrix is A by E. Do you all understand that? Right? So this distance is going to be A by E, and SB is going to be E times BM. SB is going to be E times BM, any point on the ellipse. Distance from the focus to the distance from the directrix will be E. So E times BM, E times BM means A, right? So SB is A units, yes or no, right? Now this entire angle BSB prime is 90 degrees. So from symmetry, this angle must be 45 degrees. This must be 45 degrees. Yes or no? Angle CSB is 45 degrees. And do you see that B by A is sine 45 degrees? Isn't it? B by A is sine 45 degrees is 1 by root 2. Isn't it? Isn't it? B by A is sine 45 degrees. So E squared is given by 1 minus B squared by A squared. So 1 minus half. So that makes it half. So the eccentricity of the ellipse is going to be 1 by root 2. That's going to be the eccentricity of the ellipse. Yes or no? Sounds good? Right? How is? That's the definition of an ellipse. If you have any point on the ellipse, the S is the focus, this is the directrix, then SP by PM is E. SP by PM, distance of any point from the focus to the distance from the directrix is E. So SP, so B is a point on the ellipse. So what if it's the end of the minor axis, right? Clear? SP is E times PM, isn't it? For any P on the ellipse. All right, let's move to the next one. Can I wipe this off? Now, problem 2. There is a circle x squared plus y squared equal to a squared. This is the circle. X squared plus y squared equal to a squared. Right? The center of the circle is the origin. This is the x-axis, this is the y-axis. The origin is the center of the circle. This is a circle of radius a. Now, a variable point Q is selected on the circle. Q is a variable point on the circle, right? So now, different Q's can be located by different thetas. Theta is the polar angle of Q, right? Yes or no? So which would locate Q uniquely? This theta would locate Q uniquely. OQ is A units, the radius of the circle. So the x coordinate of Q is A cos theta. This length is going to be A cos theta. And the y coordinate is going to be A sin theta. Right? Coordinates of Q would be A cos theta, comma, A sin theta. These would be the coordinates of Q. Clear? Isn't it? Now on Q, a perpendicular QM is dropped. And a point P is selected on QM. A point P is selected on QM, dividing QM in the ratio 2:1. Dividing QM in the ratio 2:1. So if I select different Qs, I'll have different positions of P. So there is going to be a locus associated with P. So I need to find the locus of this point P. While theta is varied, Q will vary, P will vary. I need to find the locus of this point P, right? Now, easy to see that the x coordinate of P is still A cos theta. That's the x coordinate of P, right? Now, the y coordinate would be 1/3 of QM. The y coordinate of P is this length, would be 1/3 this length. That means 1/3 of A sin theta, right? So the y coordinate of P is going to be 1/3 of A sin theta. So if I vary theta, the coordinates of P will vary. So at any given instant of time, suppose H is the x coordinate of P, then H is A cos theta. Y coordinate of P, K is A/3 sin theta. Now I need to connect the x and the y coordinates of P, eliminating the parameter theta, and then generalize that. That is going to be referred to as the locus of the point P. So very clearly this will give me 3K is A sin theta. Look at this equation, all that you need to do is square and add. So if you square and add, h squared plus 9k squared is a squared. And then generalize this. Replace h by x and k by y to get the locus of this moving point P while q is varied, right? So x squared plus 9y squared is a squared. And what does this represent? It's an ellipse, isn't it? Locus of P is an ellipse. And do you also see that this is like x squared by a squared plus y squared by a/3 squared equal to 1? So now the major axis of this ellipse is a units. So the auxiliary circle of this ellipse is going to be x squared plus y squared equal to a squared. That means this is the auxiliary circle of the ellipse that P describes. Yes or no? Also, the eccentricity of this ellipse is e squared is 1 minus this by this. This by this is 1 by 9, right? E squared is 1 minus 1 by 9, so which is like 8 by 9. So E then is 2 root 2 by 3. That's the eccentricity of the ellipse that P describes. Yes or no? Sounds good. Now, now one thing that I need to share with you is a physical way of looking at the ellipse, right? The equation of the ellipse is x squared by a squared plus y squared by b squared equal to 1, but it is more important to understand the physical meaning of this equation, right? Which is what I'm going to deliver to you in context of the next problem, right? Can I wipe this off and move, right? See, if this is an ellipse with semi-major axis A, semi-minor axis B, center 0, 0. And if P, X, Y, this is the major axis, this is the minor axis. This is the minor axis, this is the major axis. Right? Now if P, X, comma, Y be any point on the ellipse, the equation of the ellipse, like we've learned, is x square by a squared plus y square by b squared equal to 1. That's the equation of the ellipse, satisfied by all points on the ellipse. Now, the physical meaning of this statement is as follows. This is x units and this is y units. This x units is parallel to the major axis, right? This square, that means square of the distance from the minor axis, isn't it? This is x square is what? Square of the distance from the minor axis divided by semi-major axis squared plus square of the distance from the major axis by semi-minor axis squared is 1. That's how you want to read it? Yes or no? Physically, how you want to read x square is what? Distance from minor axis squared divided by semi-minor axis squared, isn't it? Distance from minor axis squared divided by semi-major axis squared, yes or no? Semi-major axis squared plus distance from major axis. Why is the distance from the major axis? So distance from major axis, right, squared divided by b squared, which is semi-minor axis squared equal to 1. That's a physical meaning. Now this will help if the x and the y axis are not the axis of the ellipse, right? The axis of the ellipse need not be the x and the y axis. Then this distance interpretation of the equation of the ellipse will come in handy. Square of the distance from the major axis squared divided by semi-minor axis squared plus square of the distance from the minor axis squared divided by semi-major axis squared is equal to 1, right? Essentially, the equation of the ellipse is this distance squared divided by this distance squared, isn't it? This distance squared divided by this distance squared equal to 1. That's the physical understanding of the equation of the ellipse. Yes or no? Do you all understand this? Now this is what we will put to use for the next problem, right? So problem number 3. We have an ellipse whose major axis 2a is 6, so semi-major axis is 3. 2a is 6, so semi-major axis is 3, and b is root 6, semi-minor axis, right? That means this distance is 3 units and this distance is root 6 units, right? That's given. So the major axis of the ellipse has its equation x minus 3y plus 3 equal to 0. That's the equation of the major axis, x minus 3y plus 3 equal to 0, and the minor axis has its equation, which is 3x plus y minus 1 equal to 0, which is the minor axis. And you can see that they are perpendicular to each other, isn't it? X minus 3y plus 3 equal to 0, whose axis are 6 units, yes. Clear? And you can see, now how do you find the center of such an ellipse? Intersection of the major axis with the minor axis. So if you solve these equations, you get the coordinates of the center of such an ellipse. How about it? right? Now, if I take any point on the ellipse x comma y, if I take any point on the ellipse x comma y, then very clearly distance of xy from this line, this square divided by this square plus this square divided by this square equal to 1. That will be the equation of the ellipse. Yes or no? Right? Now, distance of xy from this line is going to be what? Replace this x by this x, this y by this y, divide by root 3 square plus 1, right? Perpendicular distance of a point from a line. So perpendicular distance of xy from this line is going to be 3x plus y minus 1 by root 10 squared. Square of the distance is going to be this. Square of this distance is going to be this. Yes or no? Divided by this square. This square is 9, right? Plus distance of xy from this line. Replace this x by this x, this y by this y, and divide by root 10, right? Square of the distance of xy from this, which is like x minus 3y plus 3 divided by root 10 squared divided by 6. Yes or no? This square divided by this square is 6, equal to 1. That is going to be the equation of the ellipse. That's going to be the equation of the ellipse. Yes or no? So in this case, it's not an ellipse whose axes are parallel to the x and y axis. In that context, it's an inclined ellipse. It's an inclined ellipse, right? And the generalized equation of the ellipse will turn out to be ax squared plus 2hxy plus by squared plus 2gx plus 2fy plus c equal to 0 would be the form of the equation of an ellipse whose axes are inclined to the x and the y axis. Yes? H square less than AB. Right. So far so good? Can I wipe this off? So there is an ellipse. X square by 6 plus y square by 2 equal to 1. Right? Now there is this is the center C of the ellipse, which is 0, 0. This is the center C of the ellipse, which is 0, 0. And we are seeking to find the eccentric angle of a point P whose distance from the center is 2 units. We want to find the eccentric angle of a point P, theta is what we want to find, such that CP is 2 units, right? So now if this point is theta, then its coordinates would be a cos theta, b sin theta, where very clearly a square is 6, we'll plug in later on, and b square is 2 for the ellipse. Yes or no? A squared is 6 and b squared is 2 units. Clear? Now, distance between these 2 points is 2 units. So, square of the distance will be 4 units. So, using distance formula, a square means 6 cos square theta plus b square sin square theta means 2 sin square theta must be equal to 4. Isn't it? Now, 2 cos square theta will get absorbed with 2 sin square theta will get absorbed with 2 cos square theta, leaving me with 4 cos square theta plus 2 equal to 4. Yes or no? I hope you understand this. This I can break as 4 cos square theta plus 2 cos square theta, with that, which when added to 2 sin square theta will give me 2. Right? So this gives me cos theta equal to plus minus 1 by root 2. Right? And this clearly gives me 4 values of theta. Theta could have been plus minus pi by 4 and plus minus 3 pi by 4. These are the 4 values of theta that are obtainable from this. Now, the thing to be understood here is, so I hope all of you understand this, right? Now, what I want you to gather out of this is the following. Can I wipe this off if you're done? Right. See, in general, if this is an ellipse, this is the center C of the ellipse. These are the axes of the ellipse. Say AA prime and BB prime are the axes of the ellipse. Right? Now, if someone gives you a certain distance R0 from the center, tells you that there is a point at a distance R0 units from the center, then in general there will be 4 such points. From symmetry, you can say that there is going to be a point P R0 units, there is going to be a point P prime R0 units, there is going to be a point Q R0 units from the center, and there is going to be a point Q prime which is R0 units from the center, isn't it? So given R0, in general there are 4 possible locations of the point, which is what transpired here. Theta equal to plus and minus 4. Plus and minus 4 were first and the fourth quadrants. Plus minus 3 by 4 were the second and the third quadrants, right? 1 in each quadrant, isn't it? But somebody, if he told you that there are exactly, if someone said that there are exactly 2 points on the ellipse with distance from the center equal to say 5, then either these 2 points would be the end of the major axis or this would be the ends of the minor axis. That means either 5 would be the semi-major axis or 5 would be the semi-minor axis. But other than this, all of the points except the ends of the semi-major and minor axis would have 4 locations for a certain distance. Clear? And 1 in each quadrant, isn't it? These are also actually 4 points, but 2 coincident. This could be looked upon mathematically as 2 coincident points. This also as mathematically 2 coincident points. So mathematically 4 points, but actually 2 points. This is how we want to look at it. Clear? Number 5. There is an ellipse S which is x square by 16 plus y square by 9 minus 1 equal to 0 is an ellipse. And there is a point P alpha comma minus alpha lying inside the ellipse. There is a point P alpha comma minus alpha lying inside the ellipse, right? We want to be able to find the range of alpha for which this point will lie inside the ellipse. See, a point x1 y1 lies inside the ellipse S1, if S1 is less than 0. That means if the value of S at x equal to alpha and y equal to minus alpha is less than 0, then this point would be lying inside the ellipse, right? We've discussed that. So S, the value of S at x equal to alpha and y equal to minus alpha must be less than 0, right? So that means alpha squared by 16 plus minus alpha squared by 9 minus 1 must be less than 0, giving me 25 alpha squared less than 144, or alpha squared less than 144 by 25, which gives me alpha less than 12 by 5 but greater than minus 12 by 5. Yes or no? So alpha must belong to the interval minus 12 by 5 to plus 12 by 5. That's the interval to which alpha must belong, so that the point P lies inside the ellipse. All's good? Hmm? Shall we proceed? Number 6. So we have an ellipse designated x square by a squared plus y squared by b squared equal to 1. That's the ellipse. We want to find the locus of the foot of the perpendicular from the center onto any tangent of the ellipse. That means now this is the center C, which is 0, 0, right? And this is a variable tangent. This is a variable tangent. From C, we drop a perpendicular onto the variable tangent. Say Q. Q is the foot of the perpendicular from C onto variable tangent. So if I keep moving the tangents, the point Q keeps moving. I want to be able to find the locus of Q. Right? This is what we want to be able to do. Now in the first place, you want to represent the variable tangent with the help of a parameter, isn't it? You want to first represent the variable tangent with the help of a parameter. So you could say, well, the tangent is designated as y equal to mx plus root a squared m squared plus b squared. If m is a parameter, this will represent the entire set of tangents to the ellipse. Yes or no? Right? Now, for a given m, let's say q has coordinates h comma k. Yes, q will lie outside the ellipse, because on the tangent there is only one point that touches the tangent. All other points on the tangent will be outside the ellipse only, right? Now I want to find a relationship that connects h with k and independent of the parameter m, that means true for all tangents, and then go ahead and perform the last rights on it, that is generalize, replace h by x and k by y. Right? That's what we want to do exactly. Now, look. So hk moves, designating a moving point q. The slope of this line realizes k minus 0 by h minus 0 is the slope of this variable perpendicular, right? So the slope of the tangent then for such an hk would be minus h by k. Yes or no? Now, for any given tangent, hk must lie on this. Hk must lie on the tangent, right? And the m must be minus h by k, right? So this m can be replaced by minus h by k, x can be replaced by h, and k by y by k. That way we would have eliminated m and we would have connected h and k, and we would be ready to generalize, right? So replace y by k, y equal to k, x equal to h, and m equal to this. A squared, m squared is h squared by k squared plus b squared. Which gives us k squared plus h squared whole squared by k squared on squaring. Right? Transposing this on this side and squaring is a squared h squared plus b squared k squared by k squared is what we get. Transposing this on this side and squaring both sides. This is what we did here. Clear? K squared. And then generalize this. Replace h by x and k by y. That's the locus of Q. That's the locus of Q. Right? There isn't a name given to every kind of curve. Right? It's for sure a 4th degree curve. Right? You can have curves of 4th degree, 5th degree, 6th degree, up to 2nd degree. Falls within the jurisdiction of organized education in coordinate geometry. After second degree, you call them by third degree. You know, if a parent has 100 children, he can still give names, let's say. But after, let's say, Ram, Shyam, etc. After that, he would have to designate them by 100, 100, 200, 304. Right? That's the reason. So, there isn't a name given to this. So, you have the choice of giving it a name. Call it abracadabra. Right? Shall we move then? No. Ax squared plus 2hxy plus by squared plus 2gx plus 2fy plus c equal to 0 will either represent, your attention please, hello, will either represent a null set, means nothing, will represent a pair of straight lines, something, circles, parabola, ellipse, hyperbola. That far, or if nothing, then there will be a null set. There could be a null set also associated with it. How? Say for example, if I had 2 into x plus y minus 3 whole squared plus 5 into 2x minus y plus 9 whole squared equal to minus 6. This would be a second degree curve, isn't it? Ax squared plus 2hxy plus by squared. But do you realize this is non-negative, non-negative, goddamn negative. So this has to represent a null set. No xy will ever satisfy this, isn't it? So this is a null set. So a second degree equation could also represent a null set. Can you find a real x and y satisfying this? No. Now, there is an ellipse x square by 16 plus y square by 9 equal to 1 is an ellipse. And this is a line, say x plus y equal to 10. Different points on the line are at different distances from the ellipse. Different points on the line are at different distances from the ellipse, isn't it? If you take a point, then, and even for a given point on the line, you would find different distances from the ellipse, right? So for any given point on the line, you would have infinite number of distances from the ellipse. From another point, again infinite distances. So of all these distances, I want to be able to find the shortest distance between any point on the line and a point on the ellipse. Of all the distances that you can find between across various kinds of points lying on the line and the ellipse, the shortest possible distance is what we are seeking to find. Now I've told you on a passing remark note that if there are two curves, then the shortest and the greatest distance between them will lie along a common normal, right? Remember? So a normal to a line is only a perpendicular to the line, right? And that perpendicular to the line, we want it to be normal to this ellipse. Then it will become a common normal, right? And then that segment will represent the shortest distance. Clear? So we pretend to have knowledge of this line, PQ, the line of shortest distance, which is perpendicular to the line and is a normal to the curve, right? Normal to the curve means what? If this is a normal to the ellipse, then it will be perpendicular to the corresponding tangent to the ellipse, tangent at Q. Yes or no? Right? A normal to an ellipse is always perpendicular to a certain tangent to the ellipse, isn't it? At the point of tangency, isn't it? And if this line is perpendicular to this as well as to this, that means x plus y equal to 10 and this tangent must be parallel to each other, right? That means this must be some x plus y equal to lambda kind of a thing. That must be the equation of the tangent. Yes or no? Clear? Now, for this to be a tangent, see, this line could have been, I need to find lambda so that this becomes a tangent. I need to find lambda so that this becomes a tangent. That means a tangent of slope 1, a tangent of slope minus 1, a tangent of slope minus 1, right? So, this line can be written as y equal to minus x plus lambda, right? M is minus 1 and c squared is lambda squared, right? But for tangency, c squared, that is lambda squared, must be a square m square plus b square, isn't it? C square must be a square m square plus b squared. That's the condition for a line to be a tangent to a standard ellipse. C squared, lambda squared must be a squared, that is 16 into m squared, which is 1, plus b squared, that is 9, a square m square plus b square is 9. So lambda could have been plus minus 5. Yes or no? Very clearly, there are two tangents of slope minus 1. One would be this tangent, one would be this tangent. The question is whether to subscribe to a value lambda equal to plus 5 or lambda equal to minus 5. That's the only thing that we need to decipher at this instant for this. So once I have found lambda, then all that I need to do is find PQ, which is the distance between two parallel lines, which is going to be mod of lambda minus 10 divided by root 2. Is going to be the distance between these two parallel lines. Clear? Now, a laymanish common sense approach to the whole thing. Okay? Whether lambda should be plus 5 or lambda should be minus 5, right? See, this is the line x plus y equal to 10. Okay? This is the line x plus y equal to 10. Now, suppose this is x plus y equal to minus 5. Suppose this one is x plus y equal to minus 5 for the sake of argument, right? Then the tangent here must be x plus y equal to 5. Right? That means if this was P, this was Q, and say this was R, then this would be x plus y equal to 5. Yes or no? Now I claim that this cannot happen. I claim that this cannot happen. See, if there is any line x plus y equal to some c, then on this side of the line c will either increase or decrease. It cannot increase and then decrease. On this side of the line, all lines would be x plus y equal to c1, c2, c3, c4. Then c's will either increase or decrease. In a given direction, if you move along a line, then the c's will show a trend, either an increasing trend or a decreasing trend. Suppose this was the case, then it has first decreased and then increased. This is not possible. But if this was 5 and this was minus 5, then it's fine. It's decreasing 10 to 5 to minus 5 and so on and so forth. So this must be lambda equal to plus 5. That's a very simple common sense approach to the whole thing. So lambda equal to minus 5 is therefore ruled out given this. Lambda must be 5 for this. The other tangent, the other end of the normal would be x plus y. That means the tangent parallel to this somewhere else will be x plus, it need not be this point r, by the way. It need not be a tangent at this point r. It need not be a tangent to this point r. Another tangent with slope minus 1 would be somewhere here, say, would be somewhere here. And they need not have a common normal. They may have parallel normals. They don't need to have common normals, right? So this is not the r which I meant. This r was just some point. So then lambda equal to 5. Now PQ is what? Distance between these two parallel lines. The shortest distance is PQ, distance between these two parallel lines. PQ then, the distance between these two would be mod 10 minus 5 C2 minus C1 divided by root a square plus b squared. 5 by root 2 is the shortest distance. A cos theta, B sin theta minus, yes, I know. Reason I did not do that is because I want people to get used to this. See, in this case, that could have been deployed, but in a more complicated situation where this was not a straight line, but was a complicated curve, then this would be a superior way to handle any generalized situation. I could have done it, and yes, for this problem, taking this point as A cos theta, B sin theta, and finding the shortest distance, the corresponding theta, would have been a good idea. Right? And it would have been a one-line situation. Let me demonstrate that to you as well. But despite that method being superior for this problem, I did not discuss that because this is universal in its field. Right? But let me tell you what Raj might have done. Can I wipe this off? So, without getting into all this, he said, well, what was this ellipse? X square by 16 plus 9 equal to 1. Okay. Now suppose I took this point as 4 cos theta, 3 sin theta, A cos theta, B sin theta. Right? PQ, the distance between this line and this point, is going to be 4 cos theta plus 3 sin theta minus 10 divided by 5 by root 2. Yes or no? Yes. No, I will not use calculus. I would use ordinary, very ordinary trigonometry, in the sense that 4 cos theta plus 3 sin theta is always less than or equal to 5 but greater than or equal to minus 5. Yes or no? So when this becomes equal to 5, this would be mod of 5 minus 10 by root 2, which is 5 by root 2, minimum possible distance. Yes or no? This is the approach that could have been deployed. Got me? So it's a good thing for this problem, but not necessarily the best thing to do in a generalized situation. Right? Can I wipe this off? Number 8. So there is an ellipse. If nothing is given, might as well use convenience. 1. The center of this ellipse is 0, 0. And there is a variable normal at any given theta. The normal at any given theta, normal at theta, can be given by ax sec theta minus by cosec theta is a square minus b square. That's the normal at any given theta. If you draw different normals at different thetas, you get different equations, right? Now, for any given normal, this would be the distance between the center of the ellipse and the normal. We want to be able to show that no matter what point you choose, that means no matter what theta be, the distance between the center and the normal, that is d, does not exceed the distance between the semi-axis of the ellipse. That means it does not exceed the difference between A and B, less than or equal to this. This is what we need to show. Right? That's a problem to address. Fine? Very simple actually. See, distance between 0, 0 and this normal is given by mod of, put x equal to 0, y equal to 0, and this is, say, minus a squared minus b squared equal to 0 distance formula, distance of a point from a line. So that will be minus a squared minus b squared divided by root a square sec square theta plus b squared cosec square theta. Yes or no? This would be different for different thetas. We want to establish that this will never exceed a minus b. This number will never exceed a minus b. Very simple. Can I remove the figure from here? Now, fairly simple, because a square sec square theta this is a squared sec square theta is 1 plus tan square theta, b square cosec square theta, which is 1 plus cot square theta, right? Do you realize this can be written as a square plus b squared plus a tan theta, a square tan square theta plus b square cot square theta, I want to write as a tan theta minus b cot theta whole squared plus 2ab? Yes or no? Which is like a plus b whole square, isn't it? Plus a tan theta minus b cot theta whole squared. For any given theta, do you realize this will always be greater than or equal to a plus b whole square? Because this is non-negative, so this expression will always be greater than or equal to a plus b whole square, because this can never be negative. Yes or no? That means square root of this will always be greater than or equal to mod of a plus b, right? So if this square root of this is always greater than or equal to mod of a plus b, if it comes in the denominator, this will always be less than, minus gets hogged up by this, mod of a squared minus b squared divided by this mod of a plus b, isn't it? Square root of this would be mod of a plus b. So if this is greater than or equal to a plus b whole squared, its reciprocal will always be less than or equal to 1 by mod of a plus b. Which part? Okay. See, root a square sec square theta plus b square cosec square theta will always be greater than or equal to mod of a plus b. Yes or no? If x square greater than y square, mod x must be greater than or equal to y. That's the whole thing, right? So which means 1 by root a square sec square theta plus b squared cosec square theta would be less than or equal to 1 by mod of a plus b. Yes or no? So this is less than or equal to 1 by mod of a plus b. So this whole thing is less than or equal to mod of this by this. Yes or no? Are you still lost? No? So which is very clearly mod of a minus b. Difference between the two semi-axes. Right? Have I confused you? Oi. No? All's good, right? I mean, it could have just been used here. A square tan square theta plus b square cot square theta by 2 greater than or equal to 2ab. एक बार x1 by a squared, x by x1 by a squared minus y by y1 by b squared. Yes. Okay. Then it was predominantly algebra, and therefore, there was a mess. Because then, see, in this case, the merit here was x1 and y1 have a bondage because of theta. In the earlier situation, that x1, y1 didn't have a bondage. You had to use x1 squared by a squared plus y1 squared by b squared equal to 1 somewhere down the line, right? I know. It would have been, but good. You should experiment that too. Shall we proceed? We'll assume that the major and the minor axes are excluded from that. Yes, because in the denominator, check that out. See, what happens to the denominator? Theta for that end would be pi by 2. Yes, 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 or either tan theta or sec theta, both, right? So I think that is something that you can only judge by drawing. Okay, let's move to the next problem. See, theta equal to 0 or theta equal to pi by 2. One of the two, tan theta or cot theta, would be undefined, right? That is why it's an ellipse slides between, oh no, number 9. Find the locus of the point of intersection of tangents drawn at the extremities of a focal chord of an ellipse. No, I don't think I did this in the class. So this is a focus S, AE0. This is a chord passing through AE0, and there could also have been a chord passing through minus AE0, right? And if tangents are drawn at A and B, say they intersect at P, I draw various focal chords and I get different P's. I want to find the locus of these P's. For various focal chords, I end up getting different P's. I want to be able to find the locus of all such P's. Clear? So at any given time, let's say if this is a variable focal chord, then this is the moving point P with coordinates h comma k, right? Then the equation of AB will be t equal to 0 in terms of P. AB is the chord of contact with respect to P, isn't it? AB is the chord of contact with respect to P. AB is the chord of contact with respect to P. And its equation is going to be t equal to 0. This ellipse is x squared by a squared plus y squared by b squared equal to 1. So equation of AB as seen as the chord of contact with respect to P is going to be hx by a squared ky by b squared equal to 1. T equal to 0, right? But for all these ABs will necessarily pass through either plus AE0 or minus AE0. So x can be either plus minus AE and y will be 0 for all such chords, right? So put x equal to plus minus AE, y equal to 0, that's equal to 1. That gives me h equal to plus minus a by e. That means if this is the focus, h will be plus a by e. If this is the focus, then h will be minus a by e. That means if this is the focus, this h comma k would be on this directrix, x equal to a by e. If this is the focus, then this point P would be on this directrix, x equal to minus a by e. That means the locus of such points is the directrix of the ellipse. However, see, in case of a parabola, the tangents drawn at the extremities of the focal chord, they met on the directrix, but they were also perpendicular, because the directrix was the director circle. The directrix was the director circle of the parabola. Yes or no? But in case of an ellipse, the director circle is x square plus y square is a square plus b squared. Yes or no? So this angle is not 90 degrees. This angle is not 90 degrees in general. So that's the difference. The tangents drawn at the extremities, both in ellipse and parabola, will intersect on the corresponding directrix. If this is the focus, this would be the directrix. If this was the focal chord, then they would intersect on this directrix, right? An important property, I'm not sure if I mentioned to you, I think you just stopped me short of that property, and let me just make a quick remark on that property. Can I wipe this off and proceed? Not the polar, but can I wipe this off? See, if this was an ellipse, this was a directrix. Say this was a focus SAE0. Say the ellipse x square by a squared plus y square by b squared equal to 1. This would be the directrix corresponding to this focus. X equal to a by e would be this directrix, right? Now if I draw a tangent at a certain p, if I draw a tangent at a certain p, this is a tangent drawn at a p which is x1 comma y1. Then let me tell you, if it intersects the directrix at q, then what is PQ? PQ is the portion of the tangent lying between the point of tangency and the directrix. This PQ will always subtend a right angle at the focus. This PQ will always subtend a right angle at the focus. That's important to understand. I'll prove that in a while. PQ is the portion of the tangent lying between the point of tangency and the directrix, right? Then it will subtend a right angle at the corresponding focus. That means angle PSQ will be 90 degrees. Easy to prove proposition actually. No rocket science here. See, this is the tangent. Its equation is going to be xx1 by a squared plus yy1 by b squared equal to 1. Right? That's the equation of the tangent. Now I can find the intersection of this tangent with the directrix. I can find the equation of, I can find the point Q, the intersection of this line with the line x equal to a by e, right? Now what's the x coordinate of Q? A by e, right? Now to y, so if you plug in x equal to a by e, then the y would be y of Q in this equation. Plug in x equal to a by e, then the value of y that you get would be y of Q, isn't it? Intersection with the line x equal to a by e. So plug in x equal to a by e. If you plug in x equal to a by e, then y would be, y of Q would be 1 minus, or rather b squared by y1 into 1 minus x1 by ae, isn't it? Put x equal to a by e. So that comes here, b squared by y1, 1 minus this. That will be y of Q, isn't it? Which is b squared by y1 into 1 minus x1 by ae. Now, what is the slope of SQ? SP. y1 minus 0 by x1 minus 0. x1 minus AE, beg your pardon. y1 minus 0 by x1 minus AE is the slope of SP. Now, slope of SQ. Slope of SQ would be this minus 0 divided by this minus AE. That's going to be the slope of SQ, which is b squared by y1 into 1 minus x1 by AE divided by a by e minus AE, isn't it? Which then will emerge as b squared by a squared into 1 minus e squared y1 into ae minus x1. Yes or no? See, I hope you realize whatever I've done. AE comes here, so a squared minus a squared e squared, right? This e will get cancelled. E will get cancelled, and this is what happens, right? But b squared is a squared into 1 minus e squared for an ellipse. So b square write as a squared into 1 minus e squared. So this will become 1. So this will simply be ae minus x1 by y1. Hello. Wow. Wow, extremely melodious. Wow, Raj, wow. Very clearly, if you multiply these two, this with this, you get minus 1, yes or no? Right? So slope of SP into slope of SQ is minus 1. So SP must be perpendicular to SQ. So this must be 90 degrees. Must tell you an extremely potent property. The portion of the tangent lying between the point of tangency and the directrix will subtend a right angle at the corresponding focus. Right?
Some properties of ellipse are common with parabola, but some are not. So can we prove that these properties will be different on the basis of E or something?
We could laboriously, if we work through the whole thing, we could. Although there is a fundamental difference, one is a central conic, the other one is not a central conic. Eventually, if we start to evaluate, all of it will converge. All of it will converge. By taking values of E, we could justify, properties matching and not matching. We could justify, we could sit down and do that. I see no reason why we can't do that.
Parabola is basically a very big ellipse, extended at one end of the parabola is at one end. It is never
Right, loosely speaking. Right. So this one property I want you to take cognizance of, right? So in 10, there is an ellipse that slides between two perpendicular lines. These are two perpendicular lines. O is the origin, right? And there is an ellipse that slides between these two lines. Right. The physical character of this ellipse is not changing, its orientation is changing. Its semi-major axis, semi-minor axis will remain the same. Although its equation is not x square by a square plus y square by b squared, but its major axis will remain 2a, its minor axis will remain 2b or not to be? To be. Right. But it will keep sliding such that the x and the y axis remain tangents to the ellipse at all times. Yes or no? You know what I'm saying? Now, under such circumstances, even though the shape of the ellipse, the size of the ellipse will not change, but its orientation is varying, the center of the ellipse will assume different positions at different times, right? We then want to be able to discover the locus of the center of such an ellipse, right? Now, if C is the center with coordinates h comma k at any given instant of time, one thing that is for sure, that no matter where the ellipse lies, no matter where the center C is, the tangents drawn from O to any position of the ellipse will be perpendicular to each other. The tangents from O to any configuration, any orientation of the ellipse will be perpendicular to each other. Yes or no? The ellipse would, after a while, let's say, look like this. But the two tangents drawn will still be perpendicular. The point of tangency will vary, but the tangents will stand perpendicular to each other at all times, right? Which means what? It means that O must be a point on the director circle of the ellipse. O must be a point on the director circle of this ellipse. The radius of the director circle is always root a square plus b squared. The radius of the director circle is always root a square plus b squared, no matter what. and the director circle has a common center with the ellipse. The center of the ellipse and the center of the director circle must be the same. Yes or no? Right? O must lie on the director circle. Right? Yes or no? The radius of the director circle is this, and this will be the center of the director circle. That means the distance between O and C. O is a point on the director circle, and this must be the radius of the director circle, because the center of the ellipse will also be the center of the director circle. That means the distance OC will always be R. The distance OC will always be R. Therefore, the locus of C is a circle whose center is 0, 0 and whose radius is R. Yes or no? The locus of C will be a circle whose center is 0, 0 and whose radius is R. That means OC squared must be R squared. OC squared must be R squared. That means H square plus K square must be R squared, which is A square plus B squared. Generalize this, will give you the locus of C, which means X square plus Y squared is A square plus B squared. That's the locus of the center of such an ellipse. Yes or no? Got me? Okay. If someone said, what would be the locus of the focus? Let's find the locus of the focus of such an ellipse. Shall we do that? Same problem. Let's tweak it a little bit. Locus of the focus, or the loci of the foci. Right? Let's do that. Can I remove the clutter from here? Right? Eventually, if one occupies one position, the other will occupy that position at some time or the other. It will get rotated by 180 degrees after a while, and you would see that in that position. Yes. So which is all right. But let me find the locus of the focus. Given A and B, the physicality of the ellipse, the physical features of the ellipse remaining intact, the eccentricity remaining intact of the ellipse. Right? Now, this was some intermediate state of the ellipse. Say this was some intermediate state of the ellipse. All right. This was one focus S. Let me call it x1, y1. Let me call it x1, y1. This is another focus. So this is essentially x1, y1, and this is essentially x1, right? This is x1, this is y1. Clear? Say this is another focus, S prime, whose y is this and whose x is this. Yes or no? The y of this focus is this, the x of this focus is this. Clear? Now tell me the following. If this is an ellipse, this is a tangent to the ellipse, isn't it? The x-axis will remain a tangent at all times. The point of tangency will vary. Hello. Now, distance of the focus from this tangent is y1. Distance of this focus from the same tangent, therefore, would be b squared by y1. Why? Because this distance into this distance, product of the distances from the two foci onto any given tangent is a constant and is equal to b squared, square of the semi-minor axis. You know what I'm saying? Distance of the focus from this tangent, this is y1. Distance of the focus from this tangent must be such that this into this must be b squared. Therefore, this must be b squared by y1. Yes or no? This must be b squared by y1. So, the coordinates of S prime would be, the y coordinate would be b squared by y1. Yes or no? Now, this is the y-axis is also a tangent to the ellipse. Right? This is the perpendicular distance of this focus from this tangent. This is the perpendicular distance of this focus from the same tangent. Then do you realize this distance into this distance must be b squared? Same property. Right? This distance into this distance must be b squared. Therefore, this distance would be b squared by x1. This distance therefore must be b squared by x1. So, the x coordinate of this would be b squared by x1. Yes or no? Now, the distance between the two foci is always 2AE. That's not going to change. One focus is plus AE0 minus AE0. The separation between the two foci will remain 2AE all the time. Yes or no? Irrespective of how it orients itself. The separation between the two foci will always be 2AE. Now, the distance between this point and this point therefore must be 2AE. That means square of this distance would be 4a squared d squared. Yes or no? Right? So, the distance formula x1 minus b squared by x1 whole square plus y1 minus b squared by y1 whole square equal to 4a squared d squared. Yes or no? Right? Hey, b squared is a squared into 1 minus e squared. So, very clearly from this, a squared d squared must be equal to a squared minus b squared. See, a squared d squared must be a square minus b squared, right? So, this 4a squared b squared e squared I can write as 4a squared minus b squared. This is what I could do. So, this would connect the x and the y coordinates of the focus. Generalize this, replace x1 by x and y1 by y to get the loci of the foci, right? Yes or no? But what is there in the algebra here? It's a distance formula. One line, distance formula, nothing else. So, x1 by x and y1 by y, you get the locus of the focus of this sliding ellipse. Shall we proceed? Number 11. There is an ellipse which is x square plus 4y squared equal to 1. That's equal to 4, beg your pardon, equal to 4. That's one ellipse. And there is another ellipse, x square plus 2y squared equal to 6 is another ellipse, right? Say this ellipse is x square by 4 plus y square by 1 equal to 1. This ellipse is x square by 6 plus y square by 3 equal to 1 is this ellipse, right? Very clearly both, they have a common center 0, 0, but the major axis more than the major axis of this, the minor axis more than the minor axis. So, this will be the outer ellipse, this will be the inner ellipse, right? So, this ellipse is this, say let me call it E1, E1 is this ellipse, center 0, 0 for both ellipse. The other ellipse will be the outer ellipse. This is E2, so this is the outer ellipse. Now what is done is, a tangent to the inner ellipse, that is this ellipse is drawn. This is the tangent to the inner ellipse. Variable tangent. This is a variable tangent to the inner ellipse. Clear? and it intersects the outer ellipse at P and Q. It intersects the outer ellipse at P and Q. And then tangents are drawn to P and Q. And these tangents intersect at R. We want to show that no matter what PQ is selected, what tangent is selected to this intersection of the tangents at P and Q must always be at 90 degrees. That means what? That means we need to show that R must lie on the director circle of the outer ellipse. That means R must lie on the director circle of the outer ellipse. Yes or no? This is what we need to show. Yes or no? Right? Okay. Say R has coordinates h comma k. R has coordinates h comma k. Then what is this? A chord of contact of the outer ellipse with respect to R. Outer ellipse is this. That means PQ could be looked upon as the chord of contact of this ellipse with respect to R, which is like hx plus 2ky equal to 6. X squared by hx and y squared by ky, so that the form of tangency gets built into it, right? Plus y squared by ky, instead of y1, it's ky equal to 6. That's the equation of PQ, right? Now, this is a tangent to E1. I can apply the condition of tangency. I can apply the condition of tangency, which means if hx, this could be written, this tangent could be written as y equal to minus h by 2k into x, right? Y is minus h by 2k into x plus 6 by 2k, isn't it? Where m is minus h by 2k and c is 3 by k, or rather let me just 6 by 2k, that's c. For this to be a tangent to this, c square must be a square m square plus b square. A square is this, b square is 3. So c squared, which is 6 by 2k whole squared, c squared is a square means 36 into m squared, which is h by 2k whole squared. C square is a square m square plus b squared, which is 9, which is 3. Oh. Tangent to the first ellipse. I'm so sorry. C squared, yes, 6 by 2k whole square. It's tangent to the first ellipse. C squared is a square, which is 4 into m squared, a square m square plus b squared, right? Tangent to the first ellipse, which gives me 9, 4, h square plus k squared is 9 is what I get. Right? Multiplying by k squared, dividing by 4, so this will be 9. Right? H square plus k squared is 9. Do you realize that the director circle of second ellipse is x square plus y squared is a square 6 plus 3 9? Director circle of the second ellipse is x square plus y square is a square is 6, b square is 3, b square is 3, so which is 9. That's the director circle of the second ellipse. HK therefore lies on the director circle. The point R lies on the director circle of the second ellipse. Therefore the two tangents meeting at R must be perpendicular. Assume it to be tangent. No issues. Could do that. You could do that. Right. Let's look at problem number 12. Number 12. So the two foci S 2 comma 4 and S prime, which is 14 comma 9, are the two foci of a certain ellipse. Are the two foci of a certain ellipse. And that ellipse touches the x-axis. That means the x-axis is a tangent to the ellipse. X-axis is a tangent to the ellipse. We want to find the eccentricity of such an ellipse. We need to be able to find the eccentricity of such an ellipse, right? Now, what is this distance? Distance from the x-axis would be the y-coordinate of the point, 4, yes or no? What would be this distance? Distance of S prime from this would be the y-coordinate of the point, means 9 units. Distance from the x-axis would be the y-coordinate, right? Yes or no? And do you realize that if this is P and Q, then this is the perpendicular from this focus onto this tangent. This is the perpendicular distance from this focus onto the same tangent, and the product of these perpendiculars must be b squared, square of the semi-minor axis. So that way we know b squared right away. B squared therefore is 36. B is therefore 6. B squared is 4 into 9. Product of the perpendiculars from the two foci onto any given tangent is square of the semi-minor axis of the ellipse. Now, the distance between the two foci is always 2AE. The distance between the two foci will always be 2AE, right? Which means now this distance, square of this distance, 144 plus 25, isn't it? Is 4A squared E squared, right? So A square E square I can write as A square minus B squared. This is 169, isn't it? Square of this distance, 144 plus 25, that is 169. That must be 4A squared E squared. But 4A squared E squared is A squared minus B squared, isn't it? And B squared we know is 36, so I know A, right? I know A. So if I know A, then I know A squared E squared, and I can find the eccentricity of the ellipse. Could do that. Clear? So if you know A and B, you can find eccentricity, 1 minus B square by A square, isn't it? B is known, A can be computed from this, then the eccentricity could be obtained, right? Whatever it turns out to be. Clear? Can I wipe this off? X by A plus y by B is root 2 is a touches x square by A squared plus y squared by B squared equal to 1 at the point P. We want to find the eccentricity of the point. Find the eccentric angle of P. It should be find the eccentric angle of the point P where this line touches this curve, right? So very clearly, if theta was the eccentric angle of the point which represents this tangent, then x cos theta by A plus y sin theta by B must be 1, right? If these two tangents are the same, then very clearly I could have rewritten this tangent as x by A root 2 plus y by B root 2 equal to 1. These two lines are identical, right? So cos theta is 1 by root 2, sin theta is 1 by root 2. So theta must be pi by 4. So the eccentric angle of the point where this line touches this curve is pi by 4. Yes, you have a question. This is the ellipse. This is a tangent. Suppose this is a tangent at a point whose eccentric angle is theta. Then the same line can be written as x cos theta a y sin theta by b equal to 1. This line is identical to this line. Then comparing, cos theta must be 1 by root 2, sin theta must be 1 by root 2. So theta must be pi by 4. So the eccentric angle of the point of tangency must be pi by 4. Is that all right or not all right? All right. Can I wipe this off? So there is an ellipse. This is an ellipse, and we want to be able to find the equation of the two directrices of such an ellipse. Okay? Now this I can write as x plus y minus 5 whole squared by 4 plus x minus y plus 7 whole squared by 6 equal to 1. Now, look, very clearly, this must be x plus y minus 5 equal to 0 must be the major axis of the ellipse, because this number is small. Above this will give me the major axis. Yes or no? So, the major axis of the ellipse must be x plus y minus 5 equal to 0. And this line is very clearly perpendicular to this line. So this must be x minus y plus 7 equal to 0, the minor axis. And the point where they intersect will give me the center of the ellipse. Clear? Now, essentially, distance of P from this line squared divided by this square, distance of this line from this line divided by this square equal to 1 is the equation of the ellipse, right? What is the eccentricity of this ellipse? 1 minus 4 by 6, isn't it? 1 minus 4 by 6. That means E must be equal to root 2 by 6. That means 1 by root 3 is the eccentricity of this ellipse. Equal to 1 by root 3 is the eccentricity of this ellipse, right? Now, do you really think a square is 6 and b square is, a square is 6 and b square is 4? No, no. We will have to normalize this in the sense that I would have to write this in terms of, see, distance of any xy from this line squared divided by square of the semi-major axis, etc., equal to 1, etc. So distance of xy from this line is x plus y minus 5 by root 2 whole squared divided by 2. Distance of xy from this line is x plus y minus 5 by root 2 whole square, right? Plus distance of xy from this line is x minus y plus 7 by root 2 whole squared by 3. That must be 1. Now a square will be 3 and b square will be 2. Isn't it? Now it's reduced to that square of the distance from the major axis divided by square of the semi-minor axis, square of the distance from the minor axis divided by square of the semi-major axis equal to 1. It's reduced to the form that we are used to. So a square must be 3 square of the semi-major axis and b squared must be 2. Now in this case it didn't make a difference because, you know, the factor 2 and 2 cancelled off. Therefore, even though I computed 1 minus b square by a square this way, it was technically incorrect but didn't give me a wrong answer, because The factor 2 was common. When I divided, the factor 2 got cancelled and it did give me a right answer. But realistically, it should be looked upon as 1 minus 2 by 3 as e squared, which will give me e equal to 1 by root 3 as we had got earlier. So far so good, right? Now, can I wipe this off? No confusion? Now, what I suggest, see, the directrix will always be aligned parallel to the minor axis, isn't it? So if this is the minor axis, the equation of the directrix would be x minus y plus lambda equal to 0. Would be the equation of the directrix, because it will always be parallel to the minor axis, yes or no? The directrix is always parallel to the minor axis, isn't it? And the distance between the minor axis and the directrix will always be a by e, isn't it? Will always be a by e. That means lambda will be such that the distance between these two lines must be a by e, right? That means distance between these two lines is what? Mod of lambda minus 7 divided by root 2 is the distance between these two parallel lines, and that must be equal to a, which is root 3, divided by e, which is 1 by root 3, which is 3. Bolo, Raj. All's good? Lambda could be found from these considerations. Distance between these two lines, mod of lambda minus 7 divided by root 2 is the distance between these two parallel lines, must be a, which is root 3 divided by e, which is 1 by root 3, which makes it 3. Huh? There could be a mistake. It's matching?